Hi and welcome to Geeks for Geeks. Let us discuss this problem. In this problem, we are given a grid that is basically a matrix. Okay, so if you are given a grid mentioned in the question, you can take it as a matrix with dimension rows multiplied with columns. So this indicates the number of rows, this indicates you the number of columns. So a multiplication of both would give you the number of cells. So this represents the number of cells with the rows and the columns. Then there are two players. First is John and the next one is Arya. Okay, and they can move the coin over the matrix satisfying the following rules. So let us see what are the rules. Okay, let us draw a 1 cross 2 matrix. So this is 1 1, this is 1 2. Okay, now there would be a coin and the starting point of that coin is 1 1. Now John would be the first person who would start playing this game, and then they both would move alternatively. Alternative means that John would play first and then Arya, then again John, then Arya, then again John, then Arya, and this would go on till the game ends. Now they can move the coin by, after they can jump the number of rows by 1, by 2, by 3. So suppose I am at this position, I can take a jump to this, I can take a jump to this, I can take a jump to this, I can take a jump to this. Okay, and more jumps. Okay, now we can go and jump a column of 6. So we can go here, that is jump of 1, jump of 2, jump of 3, jump of 4, jump of 5, and jump of 6, so on. Okay, so let us delete this and see. Okay, so now you need to remain inside the grid. Okay, you can't go outside the grid. The grid that I was showing, the iteration was just for demonstration purposes only, but you need to remain inside the grid. Now if we are remaining inside the grid, as you can see, we are just moving forward in terms of both rows as well as columns. So if you are at the end of the rows and columns, then neither you can increase the number of rows, neither you can increase the number of columns that is inside the grid. So if I am currently at this position, then neither I can increase the number of rows, neither I can increase the number of columns. Now if I am at this position where I can do nothing, that means the next person who can't perform any operation to this would lose the game. Now they both play optimally. We see a lot of problems in game theory problems, particularly we see that it is written that both players are playing optimally. What do we mean by this? This means that at the current scenario, both of them would make the best decision that is available to them. Okay, this is it. Now we start from row 1 and 2 columns, and we start from this. So what John would do is he would try to play the most optimal path. So now there are 3 options available to him. There are total 9 operations available to him, but the only allowed operation so that he would be inside the grid would be just 1 itself. So he would come at this point and he would see that the other person won't be able to do any more operation. So if Arya is not able to do any operation, that means John would win. This is why John is the output for this particular test case itself. Okay, now let us move forward. Let us draw a 3 cross 3 matrix. So now let us discuss the scenario. This is 1 1, this is 3 and 3. So what, suppose I am at 2 3, then what, suppose this point here is John. So what John would do is John would make him jump at this position and he would win. Now to solve this problem, who would win? What we can do is we can see when John wins or when John loses. So if we can get a value of either of these, that means we can declare a winner. So let us first take the first scenario where John would win. So now there are many possible scenarios. We need to see if the next move is feasible and if the next move would lead us to the last cell or not. So if we are considering the last one, that means we need to consider all the past events also. Okay, so yes, this is feasible, but before trying to find a solution, let us see the next one also, so that if the next one is more simpler, we can go with that also. So if let us go to this one, that when John lose, when would John lose? Basically, John would lose if, suppose, there is, this is row and column, if there is r plus 1, if this is r plus 2, if this is r plus 1 and column, this one is r plus 2 plus column, this is r plus 3 plus column. If this is the scenario, what John would do is, John would directly jump into this and he would make lose the other person. But the scenario reverse when we remove this. So if there are less than this cell, what John would do is, John would come at this place, okay, end at this position, then the other person would take this much and John would lose in this condition. So we can see that if there is remaining, if there are remaining cells even after John's step, that means Arya would win. Okay, now the next test case would be when the, so how many jumps we can make? We can make 4 jumps in terms of columns and we can jump 7 steps in terms of rows and columns. 7 jumps in terms of columns and 4 jumps in terms of rows. How we can do that? It was given 3 and 6, but what we can do is we can try to make it 0 0. The starting point would be 0 0, so that we can get the remainder effectively. Okay, why? Because if we multiply, if we have 1 initially only, that means the modulo would be 0, but we can start from 0 0 so that we could know that when we are reaching the end itself. Okay, this is just to start from the very beginning. Otherwise, that modulo thing, that number of steps remaining would be given by modulo, and the modulo thing would work when it is 0 0. That means when it is 0 0, then only we would get the value if we are getting the value 2. So there are 2 things what you can do. After you take the modulo, you subtract 1, or you subtract 1 initially only. This is what you can do. Okay, now let us move to the implementation and you would get a better idea of it. Now let us start the implementation. So first we would swap the values rows into columns because they are given inverted. Now what we would do is we would simply check for rows and columns, but before doing that I would do 0 0. The starting point would be made 0 0, r minus minus and c minus minus. Then if the rows modulo 4 would be equal to column modulo 7, if this condition is same, both have same cells remaining, then the first John would take and then Arya would take and he would win. Why? Because I'm telling you, suppose if there is some cells left, there is 1 cell left, there is 1 cell left, then what we would do is John would take the first step and the next step would be taken by Arya, and the remaining step can't be taken by John, so Arya would win. So I would just return Arya. Okay, now if this is not the condition, then you can write else also, but as if the control of the program reaches at this point, then the control of the program already goes back. Okay, this function is complete, so we can directly write the next return function also. So if the control of the program has went to the line number 16, this means the line number 13 is false. So what we would do is we would just write John itself and then we would end this. Let us see that, let us compile and run. And yes, we are getting a correct output for this. And yes, we got an AC. Thank you. Have a nice day. All the best.